Welcome. In this session on natural deduction, we'll explore one way that we can combine predicate logic with propositional logic. Suppose that what we want to do is we want to show that from everything being either not P or being Q, we can conclude that everything that is P is also Q. And the way that we would do that is we would set up a proof. So our proof will begin with a premise, which is for all x, the negation of P is conjoined with Q. So that is a premise. And I'm thinking this might be a long proof, so I'm going to leave quite a bit of space here. And I'll say that the conclusion is that everything with the property P has the property Q. And as usual, I'll take a look at my premise, take a look at my conclusion, and say, what's my strategy? And here, from previous sessions, I remember that the forward reasoning strategy wasn't very fruitful, so I'll immediately go to a backward reasoning strategy. And that is, I want to introduce this quantifier. So what I want to do is I want to introduce it by assuming, for the purpose of argument, a fresh variable. And I do that by opening an assumption box. So I'll open the box, and I'll say that the justification immediately is this will be universal introduction. The box will start at line 2, and I don't know how far the box will go. I'll introduce, let's introduce W this time. And then I substitute W into this formula, provided that this formula is free for W. That is, by the substitution, W doesn't then become bound, and that's true in this case, so I will say that that is P of W material implies Q of W. I now take my assumption and ask myself, what from the preceding lines of the proof that are within scope can I do? And I see that, oh, I could do universal elimination, and I could then break this down. I see that my goal formula is really a statement in propositional logic, right? It's an implication. And if I do this substitution, I have a disjunction, and now I'm back in the world of propositional logic. So that's what I'll do. I'll say that line 3 of my proof is I'll substitute W into this formula, and my justification for that is universal elimination of line 1. I now have a choice. I could either use forward reasoning and use disjunction elimination, or I could use backward reasoning and do implication introduction. I'll choose to do it by forward reasoning, and you could try, for example, doing this with backward reasoning. So if this was forward reasoning, I would have 2 new assumption boxes, and these would be nested inside. So this would be one assumption box, and this would be the next assumption box. The justification for this is that is disjunction elimination, and that is based on line 3, and the first box must start at line 4, so I can fill that in, and I don't know where that second box will start or end. I then take the left disjunct and put it into the top of the first box, so that is the negation of P, and that is an assumption. I take the right disjunct and put it as the top line of the second box, So that is Q of W is an assumption. And I then take the goal formula and put that as the bottom line in each box. So that will be P of W material implies Q of W. P of W materially implies Q of W. I'll start with the top box. I then say to myself, if I take this and everything else that's within scope, what can I do? And the answer is I'm not seeing anything immediate. I look at the conclusion, at the goal formula, and I say, oh, the goal formula is an implication. I could use implication introduction. Am I allowed to do that? Well, yes, I can nest these boxes quite deeply if I have to. So I will open up a new assumption box. The justification for this line is implication introduction. It will begin at line 5, and I'm not sure how far it will go. I take the antecedent and make that an assumption. And I take the consequent and make that my new goal formula. I then ask myself, what can I do with this new assumption and everything that precedes it in the proof that's within scope? And my answer is, I see P of W, and then I immediately above see not P of W. Well, I could use negation in elimination to get the bottom symbol. I'll do that. That leads to a contradiction, and I know that a contradiction is a technically really useful thing to have in a natural deduction proof. So that would be line 6, and it's justified by negation, elimination from lines 5 and 4. I then ask myself, how can I go from a bottom symbol to any formula at all that is useful in my proof? And the answer is, oh, that is bottom elimination of line 6. And that becomes line 7 in my proof. I now have completed this box, so the goal formula is justified, and it's justified by a box that starts at 5 and ends at 7. And I can now go to my second disjunction box. Again, I see that this is an implication, so I will open up a new assumption box, and I put the antecedent at the top of it, and I put the consequent at the bottom of it. And I say that the reason for this is implication introduction. This is line 8, this is line 9, this is line 10. So that begins at line 10. This is an assumption for line 10. And then, oh, what's my justification for this? Well, this is one of those rare situations where in software it would just automatically fill it in for you. But here we'll actually just note for human purposes that that's a copy of a previous, which is line 9. I've now completed this second implication box, so that justifies the implication introduction in a box that starts at line 10 and ends in line 11. That is now line 12 of my proof. I've completed this disjunction box, I've completed this disjunction box, and that means that this formula is now justified. So I can deduce that P materially implies Q based on line 3 is my disjunction, the first box starts at 4 and ends at 8, the second box starts at 9 and ends at 12, and that is now a line in my proof. And this big assumption box is now complete. So this line is justified by a box that began at 2 and ends at 13, and that is line 14, and my proof is complete. So what I've done here is I used backward reasoning with predicate logic to get one assumption box. By doing that, and then I applied forward reasoning to get rid of this universal quantifier. That put me back in propositional logic. I had a choice. I could have used disjunction elimination immediately, that's forward reasoning, or I could have used implication introduction first. That would be backward reasoning. I chose to go forward. One good homework problem for you to do would be, you could redo this inner part of the proof, and you could do it using backward reasoning first.